So these are going to be the notes for a system of nonlinear equations using substitution. So a system of two nonlinear equations and two variables, also called a nonlinear system, contains at least one equation that cannot be expressed as in the form of ax plus by equals c, which is a line. All right, so the directions for 1 through 4 to say to solve by the substitution method. So what you're going to do is pretty straightforward. You're going to look at your two equations. For here we have x squared equals 2y plus 10, and since we have that squared term right there, we know that's going to be a parabola. And for the second one, we have 3x minus y is equal to 9, which is a line. Okay, so you want to pick the easiest one to solve for a variable. I'm going to pick the second equation, the line, and it's pretty straightforward. I'm just going to subtract the 3x, then negative y equals negative 3x plus 9. Then I'm going to divide by negative 1. Then I get y equals 3x minus 9. So I'll be using this equation and my very first one here. So you'll notice that I have it solved for y. So all I'm going to do is substitute this expression here into the first equation for y. And what that's going to look like is this. We're going to have x squared equals 2. Y changes to 3x minus 9 plus 10. And we're just going to simplify this, distribute 6x, negative 18 plus 10. We can combine negative 18 and positive 10. Now we're going to bring everything to one side. So I'm going to bring it to the side of x squared. So I'm going to subtract 6x and add the 8. And this brings me to x squared minus 6x plus 8 is equal to 0. The reason I brought everything to the same side is because I saw that it was a quadratic function. So in order to factor, whether it's factoring or, the quadratic formula, we're going to go ahead and factor this. So we have negative 6 and positive 8. We're going to divide by 1x. And that's going to be negative 4 and negative 2. So we have x minus 4, x minus 2 as our factors. If you set each one equal to 0 and solve, you get x equals 4 and x equals 2. Alright, now you're going to go back and take those answers and plug it back into one of your functions. And for me, the easiest one is going to be the one that I solved for y. So that's y equals 3x minus 9. So y equals 3. We're going to change x to 4 minus 9. 3 times 4 is 12 minus 9, which is 3. So now we have an ordered pair of x equals 4, y equals 3. So I'm going to write 4 comma 3 as my answer. That's where my line and parabola intersect. And my second one is going to be y equals 3 times 2 minus 9. 3 times 2 is 6. 6 minus 9 is negative 3. So now we have x comma y. And those are our two lines where they do intersect. All right, for the second one, for the next one, I'll just keep it consistent. I'll solve for y again. You can actually solve for y in the first or the second one. I'll just go ahead and solve for the second one. So I'm going to start by subtracting 4x. And divide by negative 1, which is just really just flip the signs. So we have y equals 4x plus 1. So notice the two equations I'm circling. That's what I'm going to do. Notice this one says y equals, so I'm plugging in for y. So x squared equals, and we change the y to 4x plus 1, and then minus 1. So we see that the 1's do cancel out to give you 0 here. And so when I rewrite it, I get x squared equals 4x. And just like previously, if there is a squared term, you move everything to that side to make it positive. And we get x squared minus 4x equals 0. This is a GCF. They're both divisible by x. Now we set each one equal to 0. So if we set x equal to 0, we get 0. And x minus 4 equals 0 is 4. So now we plug it in. So I'm going to use this equation I solved. So y equals 4 times 0 plus 1. So y equals 1. So my first order pair where they intersect is 0, 1. Y equals 4 times 4 plus 1. 4 times 4 is 16. And 16 plus 1 is 17, so that's going to be 4 comma 17. All right, on to number 3. All right, for number 3, you'll notice we have a line this time, and this time we also have a circle this time instead of a parabola. All right, so here it looks like the line is going to be easiest to solve, and I'll solve this for x because x is positive. So all we're going to do is we're just going to add the y to the other side. So we get x equals y plus 3. And since this is solved for x, we're going to plug this in for x in this equation. So parentheses y plus 3 minus 2 close parentheses squared plus, here we're going to do y plus 3 squared is equal to 4. And then we get y plus 1 squared plus y plus 3 squared equals to 4. So what we're going to do to solve this is we're going to first write the y plus 1 squared twice, so we can FOIL that out. And we're also going to write out the y plus 3 twice and FOIL that out. And don't forget that plus sign in the middle and bring down your 4. So you get y squared plus y. And we get y plus 1. And y squared plus 3y. And then we get 3y plus 9. All right. So we have y squared plus y squared, which is 2y squared. Then we get 1y plus 1y plus 3y plus 3y. So 6y plus 2y is 8y. And then 1 plus 9 is 10 is equal to 4. We can subtract that 4 over. So we get 2y squared plus 8y plus 6 is equal to 0. X method. 8 on top, dividing by 2y. And then a times c is 12. So my factors would be, let's see, 6 times 2. This becomes 1 over y, 3 over y. So we do come up with y plus 3 and y plus 1. If we set each of those equal to 0, we get y equals negative 3 and y equals negative 1. Now we're going to plug them back into get our function. So this one right here. So x equals negative 3 plus 3, which is 0. So we get 0 comma negative 3. The other one is x equals negative 1 plus 3, which is 2. So we get 2 comma negative 1. All right. And now we move on to the last problem. All right, again, it's a line in a circle. So we'll just solve that first one for x. So we just subtract the 2y over, and we're done. All right, since this says x equals, we are going to plug in for x into this equation. So we get parentheses negative 2y minus 1 squared plus y minus 1 squared is equal to 5. We're going to write each one twice now. All right, so negative 2y and negative y is 4y squared plus 2y. And then positive 2y plus 1. Then y squared minus y. Negative y plus 1 equal to 5. So we're going to combine our like terms. So 4y squared plus 1y squared is 5y squared. 2y plus 2y is 4y. Minus y minus y, so it would be 2y. And then 1 plus 1 is 2. And then we're going to subtract this 5 over, and once we do that, we'll be able to factor. So we come up with 5y squared plus 2y is equal to, minus 3 is equal to 0. So let's go and do the x method here. So 2, a times c is negative 15, dividing by 5y. All right, here our two numbers are going to be 5 minus 3, which is 2, but also multiplies 15. So that's going to be y plus 1. and 5y minus 3. If we set these both equal to 0 and solve, we get negative 1. And we get y equals 3/5 when you add the 3 and divide by 5. All right, now we're just going to plug this into our original equations, work it out, and see what we get. So the one I like to plug it into is the one I solved for myself. So x equals negative 2 times y is negative 1, which is 2. So my first ordered pair is going to be 2 comma negative 1. And for my next one, x equals negative 2 times 3/5. And x equals negative 6 over 4, which is negative 1.5. And I see I made a small error there, so let me fix that. This was a 5 to begin with. Alright, we get negative 6/5. Let me verify this is correct. Don't make any mistakes there. 5y, so 3/5. Oops. So that becomes negative 2 times 3/5. And then we get negative 6 over 5. So we have an ordered pair of 3/5. Sorry. Negative 6/5, comma 3/5. All right, and that concludes the notes for today.